We are Group 3 from Seminar 1. I'm Emily.
I'm Priyakakshi. I'm Peter.
I'm Zikang.
And I'm Wei Bin, and today we'll be explaining our database project. Here's the agenda for our presentation.
For the ERD diagram, firstly, we identified the entities with many-to-many relationships. Then, the binary many-to-many relationships are decomposed by including a weak associative entity. Weak entities will take the primary keys of the parent entities as the composite primary keys. This table shows the entity with many-to-many relationships and the associative entity and the corresponding primary and foreign keys. We have assumed that a user can appear on a club's weekly leaderboard if and only if he or she belongs to a corresponding club. Thus, an associative entity of user club weekly leaderboard is formed between user club and weekly leaderboard to reinforce this constraint. Secondly, it was noted that the user has a many-to-many unary relationship. To solve this, we normalized by adding a new entity of followship which has user ID and following user ID as its composite primary key. The followship entity is identified as a weak entity. Next, we examined and noticed deviations from the preliminary schema. We changed some of the relationship cardinalities in the preliminary schema to better reflect the actual implementation of the database design. Two notable highlights include a user can give 0 to many kudos instead of 0 to 1 kudo, and a user activity can receive 0 to many kudos instead of an activity. These are the assumptions we have come up with when coming up with our ERD diagram. This video aims to highlight the assumptions that are pertinent to the queries which will be discussed in the subsequent parts. For a complete set of assumptions, please refer to our report. The worth mentioning assumptions include a user can follow 0 to many users. A user can be followed by 0 to many users. A user can perform 0 to many activities, and an activity can be performed by at least one user. For the user kudo tables, if a kudo is given, it is given on a user activity. Also, a user can give 0 to many kudos, but can only give 1 kudo to each user activity. A user does not need to follow another user to give the user a kudo. A user activity can receive 0 to many kudos. This is the final ERD diagram after consideration of the above-mentioned assumptions and deviations. This shows the normalized relational schema in the third NF format. For the one-to-many relationships, we've imported the primary key of the one side to the many side to reinforce the compulsory relationship constraint. For the weak entities, we have taken the primary keys of the parent entity as foreign keys and deemed them as primary composite keys as well. Next, my team and I will be going through the SQL queries now.
For SQL question 3, we need to generate a list of female users who are followed by only male users. We require the user's user ID and user's gender from the user table, and following user ID which refers to the user being followed, and user ID which refers to the user that is following another user from the followership table. Moving on to the explanation. Firstly, we will join the user table with the followership table and use the combined table to identify female users and their total follower count. Next, we will join the user table with followship table again and use the combined table to identify female users and their male follower count. Lastly, we will compare the male follower count with total follower count, and if male follower count is equal to the total follower count, we will output the result as it shows that all the followers are male users. Otherwise, there should be no output. Also note that we can use the coalesce function to exclude those female users that are not followed by anyone. Lastly, the result shows that there are 4 users who are followed by only male users.
Query 4. Generate a list of users that follow each other mutually. To do this, we'll be looking at the followship table. So, here's the code in which step 1 includes creating a table of my user ID and the user ID of the person following me, which is called U, using inner join on the followship table with itself. Step 2 would be to place a condition on the inner join to limit the entries, whereby my following user ID is equal to your user ID and my user ID is equal to your following ID, which means that the users follow each other mutually. However, this produces a result where produces a result where user ID 3 and 4 are displayed as well as 4 and 3 are displayed. So in order to reduce this, we go through step 3 where common values are removed by placing a greater than condition where my user ID should be less than my following user ID. So this would produce the final result.
For questions 5 output required, we require 3 tables: the user table, activity table, and the user activity table. For step 1, we'll find out the time each user spends exercising. The average weekly exercise time is assumed to be calculated by taking the sum of all exercise durations in February divided by 4 weeks. This is done by running the code highlighted in yellow in the slide. The right side shows the output of the users who have exercised in February. As you would have noticed, some of the user IDs are not displayed in the output table when they have not exercised at all in February. Thus, to solve this, we have adopted the following solutions highlighted in green. Firstly, we used the distinct function to ensure that all user IDs captured in the database will be reflected. Secondly, we use the Colliers function which returns the first non-null value. This is to calculate and display users who have not exercised and display the average exercise time per week as 0. For step 3, we join the user table and Feb average table to generate the activeness insight using natural join. We used natural join as it is an equi-join function where the duplicate columns are eliminated in the result table. This ensures that there is no repetition of data using user ID as the primary key. Finally, this shows an output of query 5 after considering the above mentioned steps. To generate the age-based activeness insight and gender-based age-based activeness insight, we include the group by clause using user ID and the having clause to further categorize the user ID column into subgroups of age for query 6 and age and gender respectively for query 7.
For question 9, in order to find the monthly active social network for the users, the data that we will need includes the Kudo and followship table. From step 1, the use of having count will return the rows of Kudo receiver ID who have received more than or equals to 5 Kudos. As for step 2, it will return the rows of Kudo receiver ID who receive Kudos from their follower. The use of on in step 2 is to join the two different columns, followship following user ID and Kudo receiver ID with a specific condition where the Kudo sender is the follower of Kudo receiver. The use of inner join is to give the result of the two intersections between step 1 and step 2. The table on the right shows the result for the queries.
For question 10, we need to show each user's weekly averages as well as his following's weekly averages. To do so, we need the user activity table and the followship table. Firstly, we got the user's weekly average activity duration in February by using a similar SQL code as in question 5. We also got the weekly average activity distance by modifying the same code to select activity distance instead of duration. The respective outputs are shown on the right. Then we inner join the average duration and average distance tables together by matching the user IDs in both tables to get the combined average table on the right. Next, we inner join the average table with the user ID of users whom each user is following. We did this by joining the average table as seen in the previous slide with the followship table by matching the user IDs in both tables, and we get the resulting table on the right. Then we also got the combined average table for users whom each user is following. This is done using the same code that we used to get the combined average table for each user previously. Lastly, we inner join the user's average and following table with the following user's average table by matching the corresponding user IDs to get the final table. And this is a portion of the final table. Now we'll be moving on to our non-relational database design. There are differences in design between our relational and non-relational implementations. In our non-relational database, there are a total of 4 collections as seen in the table. Each of them comprises of data from different tables in our relational database. However, there are also tables in the relational database that are not reflected in the non-relational database. These tables were not included in our non-relational database as they were not essential in answering the questions given. So moving on to queries. For question 2, we use the user activity collection, which contains user details such as ID, name, age, gender, and email, activity amount, array of activities with the corresponding activity details, kudo amount, array of kudo giver, and the users following and follower amounts and arrays that are split by gender. For our query, we used MongoDB's aggregation framework, and we used the match operation to find the documents that match the specified conditions, which are gender is male and female following amount is greater than male following amount. Female following amount and male following amount represent the number of female users and male users followed by the user respectively.
So for question 4, we are required to find out users who are following each other mutually. We will need to use the user mutual following collection, which includes user ID, following underscore user ID underscore following underscore user ID, and following underscore user ID underscore following underscore user ID. To answer the queries, we will be using MongoDB framework to find out the instances where both user ID underscore underscore user ID and following underscore user ID underscore following underscore user ID equals to yes. The results of the mutual following users are shown in the table below, which in this case will be user 3, 4 following each other, user 47 and 48 following each other, and user 59 and 60 following each other.
Question 5, part 1 requires us to create a list of users who have exercised for less than 30 minutes per week. In order to do this, we will be using the aforementioned user activity collection. However, this collection does not include a field for average exercise time per week. In order to find out the average exercise time per week per user, we decided to create a new table, which was called output. And we used this code to do it, where we added a field called average duration, which consisted of the addition of all of the activities of the user within the given time frame of February, and then dividing it by 4, which is the number of weeks inside February. This created a table looking like this, where average duration was appended as a new column next to user ID, which indicated the average duration of the activities for that user. Then, to find out users with the average duration of less than 30, we created a simple find code on the output. And this gave us the following result, in which all of the users with the average activity time of less than 30 minutes for the entire month of February was displayed.
For question 8, we have to generate a list of users who have received more than 5 kudos in average for each activity. In this query, we use the user activity collection. To find out the average kudo received, we divided the kudo amount by the number of activities. Then, we restricted the condition by using the match function in NoSQL to find the average kudos greater than 5. The output shows the user ID and the corresponding average kudos received for those user ID, with average kudos received of greater than 5 for each activity.
Moving on to NoSQL question 9. For each user, we need to list out his or her followers who have given him or her more than or equals to 5 kudos for each month's activities. We'll be making use of the user kudo collection that we have created for this query. The collection contains the user details such as user ID, name, age, gender, and email, as well as an array of followers which contains the follower's ID, name, and the number of kudos given in February and March. Moving on to the explanation, firstly, we will display the object ID, name, user ID, and follower array as highlighted in orange. Next, we will filter to obtain the array that contains the information about the followers that have given more than or equals to 5 kudos for the month of February, as most activities are done in February. Lastly, the expected result is shown with an example of 2 of Angeli's followers that has given her 6 kudos each in the month of February.
on to the advantages and disadvantages of relational databases. The main advantage of relational database lies in its compliance with the ACID: atomicity, consistency, isolation, and durability. Complying with ACID reduces anomalies and protects data integrity of relational databases by suggesting precisely how transactions interact with the database. The main disadvantages of the relational database is that information cannot be easily shared from one large database system to another as databases become increasingly complex. For instance, relational databases often grow in separate divisions in large firms. Thus, when a holistic report is needed, it can be quite challenging and expensive to retrieve all the relevant information from the different databases. Additionally, there's a chance that during the storage, the data might be lost since the relational databases place limits on the variable size. Next, we have the disadvantages and advantages of non-relational database. The main advantage of non-relational database lies in its flexibility. Data in non-relational database need not be structured in a certain way. This provides users with flexibility to structure the data in a way that's more suitable for the user's intended application without having to abide by the row-column format in a table. Therefore, the user can make changes to the database easily. A non-relational database deals with semi-structural data. Each entry fits into a single JSON record. So, a NoSQL database looks like a folder with files rather than a table. As a result, it can process any type of data without needing to modify the architecture. So creating and maintaining a NoSQL database is faster and cheaper. The main disadvantage of non-relational database lies in the lack of standardization or SQL language, which is a universal query language that all relational databases use. Hence, the design and query languages used for NoSQL databases vary among different NoSQL products. Even though it may be cheaper to develop and design non-relational databases, the training of employees to learn the different query languages may be expensive, since they differ from database to database, which results in a steeper learning curve, since programmers need to know how to use the different types of NoSQL databases. Even though NoSQL databases may have a better speed of performance since it does not comply with ACID properties, the danger is that the data on one node may be out of sync with the data on another node. Lastly, there are still many security issues regarding the NoSQL databases that require more time to be solved.
For the recommendation, we would like to recommend the use of NoSQL for the design and development of the database for the Fitness 365 mobile application. This is because there may be a possible increase in the data storage requirements in the near future. Hence, NoSQL will be able to reduce the cost of purchasing expensive hardware storage since it is more scalable and supports horizontal scaling. Also, with the possible addition of new features and functions in the future for the application, NoSQL will also allow for minimal downtime whenever we change the schema since it is highly flexible. And the minimal downtime will also retain the confidence in the users of the application. Lastly, since we'll be storing various information about the user's activeness and lifestyle pattern, NoSQL will also allow us to speed up the development process as we do not have to devote time to define the type of data to be stored.